Hello, boys and girls. Today we will see two oscillations. Means we are going to continue the topic oscillation. Last time we had considered the topic which is related to the expressions for the displacement, velocity, and acceleration for a particle performing simple harmonic motion. Now let's see some ideas about the maximum displacement, minimum displacement, maximum velocity, maximum acceleration and minimum acceleration. So while performing a simple harmonic motion, this is a simple harmonic motion. When a particle performs a simple harmonic motion, it attains minimum displacement, maximum displacement at different positions. Similarly, minimum velocity, maximum velocity, and the intermediate velocities. But minimum velocity, maximum velocity. Similarly, minimum acceleration, maximum acceleration. So let's see some important information about the displacement, velocity, and accelerations, which is very useful for the simplification of the numericals. So let's see. So minimum, maximum values of displacement, velocity, acceleration. So let us consider the first displacement as, and we know the displacement general formula is x is equal to a sin omega t plus phi. So this is the general formula for the displacement. From this formula we can find the displacement of the particle at any instant of time. At any instant of time t, and the particle may start its motion from any position. From any position in this simple harmonic motion, then we can decide the displacement of the particle from this relation. But basically, we have to consider only two positions for the simplicity or to decide the minimum values and maximum values. So, from the mean position and the extreme positions, we can conclude or we can decide whether the values are minimum or maximum. So, for the displacement, when the particle is at mean position, then the particle's displacement from the mean position will be zero. So at mean position, the displacement of the particle is always zero, because the distance of the particle from the itself mean position, it is nothing but the zero. So at mean position, displacement is zero. Zero means minimum displacement. Second, at extreme position, this position or this position. There are two positions which are extreme positions in the simple harmonic motion. When particle reaches to the extreme position, then its the displacement from the mean position, because the reference point is always a mean position. So the distance of the extreme position from the mean position, it is maximum. That means the displacement is maximum. It may be positive maximum or negative maximum. So at extreme position, displacement x will be maximum, x max. It may be positive or negative, and its maximum value is a. And this maximum value of the displacement in the simple harmonic motion, it is also called as amplitude of simple harmonic motion. Then see the velocity. We know the general formula for the velocity of the particle performing simple harmonic motion is, we know v is equal to plus minus omega under root of a square minus x square. So this is the basic formula for the velocity. So at different position, x means the position or displacement. So at a different position, we can decide the value for the velocity in the simple harmonic motion. So let's see the two position. Let's see the two position, mean position and then the extreme position. Let's say at mean position. At mean position, how much displacement? Displacement x is equal to 0. Place the value here in the basic relation for the velocity. The velocity plus minus omega x is 0, so 0 square 0 under root a square. So under root a square, its root will be a. So plus minus omega a. So this difference, when x is equal to 0, this difference becomes maximum. Because we are not going to subtract anything. Means 0 is the number which we are subtracting from the a square. Means we will get the maximum difference. Means maximum velocity. So when particle is at mean position, x is in the displacement will be 0 or x will be 0, then velocity becomes the maximum because the difference will be minimum. So velocity will be maximum, and that velocity we will get plus minus omega a. That is the maximum value for the velocity, and in other way, in magnitude form, we can write here omega a is a omega. So maximum value for the velocity we obtain at the mean position, and it has the value, or we can decide the value from this relation a omega. Then minimum at extreme position, displacement will be maximum, maybe positive or negative. Displacement will be maximum, positive or negative a. Place this value in this relation, we will get plus minus omega a square minus x square, but x square means a square minus a square. A square minus a square. So we will get the difference which is a minimum difference. Sorry, this is the maximum value. Maximum difference. So maximum value for the minimum mean position. Then at extreme position, x is maximum. Therefore, this difference will be minimum. Means the velocity will be minimum. So we minimum. My plus minus omega under root of a square minus a square is equal to 0. 0 means minimum velocity. So we get maximum velocity at the mean position and the minimum velocity at the extreme position. And lastly, see the acceleration, and we know that acceleration is omega square x. Acceleration depends only on the displacement, because omega square is constant. So displacement x, which gives the value of the acceleration in the simple harmonic motion. Let's say at the mean position, displacement is 0 is minimum. So we will get minimum acceleration. Means acceleration minimum will be omega square, x will be 0, so product will be 0. Means that is the minimum acceleration. At the extreme position, x is equal to, that is the position or the displacement, will be maximum plus or minus a. So consider the value of x which is equal to a, then we get the maximum, which will be the maximum acceleration. So omega square, x means plus minus a, after simplification plus minus omega square a. So as x is maximum, so acceleration will be maximum. So acceleration which is maximum is given by omega square a maximum or a omega square. So this is the basic and simple but also important information about the minimum, maximum values for the displacement, velocity and the acceleration. Okay, so this is all about the minimum and maximum information.